Hello everyone and welcome back. My name is Mr. Cobalt, and today in this video I am going to go over how do you determine what your limiting reagent is or your limiting reactant is. And there are two methods to do this. I'm going to start with the problem here and I'll explain each of these methods. So here we have a balanced equation of the combustion of methane. Right, so we need for 1 mole of methane to be burned, you need 2 moles of oxygen, and that's going to produce 1 mole of carbon dioxide and 2 moles of water. And so you're going to get your mole ratio here. So in your typical limiting reagent problem, they're going to give you 2 amounts of reactants, and they're not going to tell you if you have enough or not. So in a non-limiting reagent problem, they will make it very clear that you have enough of one of the reactants to completely react with the other one. So anytime they use that sort of language like completely react or you have enough or assume you have enough, it's not a limiting reactant problem. But if they just throw 2 substances to you or 2 amounts of each reactant and they ask you what's the maximum amount, then it's a limiting reagent problem. So you have to check to see which one is the limiting reactant and then go from there. And there's 2 methods to do that. The first method is whatever amounts they give you, if it's moles or grams, you want to convert both of these and figure out like how much of 5 moles of this substance will give me for my product that I'm interested in. And so let's say we're interested in the amount of, say, carbon dioxide that's formed from this reaction. So if I mix these together, how much carbon dioxide will I get? So if I'm interested in carbon dioxide, then what I need to do is I take my 5 moles and convert that to an amount of carbon dioxide. And I take my 8 moles of oxygen and I convert that to an amount of carbon dioxide, and I see which one gives me less amount of that carbon dioxide. The one that gives me the lesser amount is the limiting reagent, because as soon as I reach that amount, that reagent is gone. I have no more reagent to react because that reagent, I only have enough to make that amount. And then when I make that amount, the reaction stops because I run out of one of my reactants. This goes back to the pizza analogy I use, where we calculated from the ingredients to see how many pizzas I could get from each ingredient, and the ingredient that gave me the lesser amount of pizzas is the one that ran out first and would stop the pizza making process, right? So it's the same thing with chemical reactions. So let's go ahead. I'm going to start with here, and I have 5 moles of my CH4, and then I'm going to convert that to carbon dioxide. So I'm going to use the mole ratio from the equation, from the coefficient. So it's 1 to 1. So here, for 1 mole of CH4, I'm going to CH4 on the bottom, so because that's going to cancel out, in 1 mole of carbon dioxide. So the moles of CH4 cancel out, and I'm left with moles of carbon dioxide. So that's going to give me 5 moles of CO2, assuming I have enough of everything else. So that would be 5 moles. And then I take the 8 moles of oxygen, O2, and I do the same thing. I'm going to convert that to carbon dioxide and see how much carbon dioxide I could get theoretically from 8 moles of oxygen. So here the ratio is 2 to 1. So for every 2 moles of oxygen, I make 1 mole of carbon dioxide. So here I'm going to put 2 moles of oxygen on the bottom, 1 mole of carbon dioxide on top. And so now moles of oxygen are going to cancel out, and then I will get 4 moles of CO2. So looking at this, So now I know that my 5 moles of methane are going to create 5 moles of carbon dioxide, but my 8 moles of oxygen would only produce 4 moles maximum. So as I'm producing carbon dioxide, as soon as I make 4 moles of carbon dioxide, I have now run out of oxygen because it's all gone. I only have enough oxygen to make 4 moles of carbon dioxide maximum. So as soon as I make 4, I'm done. I have no more oxygen. It's run out. I will have methane left over because I have enough methane to make 5 molecules. But when I make 4, the reaction stops because I run out of oxygen. I have no more oxygen, so I stop at 4. So since the least number here is 4, then the reactant that gave me the lesser number is the reactant that's limiting. It limits the reaction. So whatever reactant that gives me the lesser amount is the one that's limiting how much I can make. So in this case, oxygen is the limiting reagent or reactant. Okay, so and then my reagent that's in excess would be the methane. I have leftover methane. Okay, so this is the first method that you would do to find out what your limiting reagent is. And this would work if you were given grams. So if this was, instead of 5 moles, you were given 5 grams and 8 grams, you could do the exact same thing, except you would have an extra step. You would need to convert grams to moles first, and then use the mole ratio in your equation to convert to moles of your product. So you would have an extra step, right? And also, if the problem was asking you to give a mass in grams of a particular product, then you would eventually have to convert the moles of the product, whichever one gave you less. You would continue with this amount, and then use the molar mass to convert from moles to grams, because that's what the problem would be asking for. So where you start with grams or moles, depends on what they give you in the problem. So if they give you moles, then you start with moles and you convert using the mole ratio. If they give you grams, then you start with grams, convert the grams to moles, and then use the mole ratio to convert to your product, and then you compare which one gives you the lesser amount. So it just depends on what they give you in the problem. Okay. So the second method is where instead of converting both of your reactants to a given product and then seeing which one gives you less, you can convert one reactant to another and see if you have enough of that reactant to react completely. So in this case, so here, since they give me 5 moles and 8 moles, I can use my mole ratio and then convert one of these to the other and then compare how much I actually have. So for example, let's take the methane. So I have 5 moles of methane, CH4, and I can use the mole ratio to convert this amount of moles of methane to the amount of oxygen I would need to completely react with all of my methane, right? So if this is what I have, then I'm going to figure out, well, how much oxygen do I need to react completely with the methane? And I'm going to use my mole ratio here. So 5 moles, I have moles of methane, so 1 mole of methane on the bottom, so 1 mole of CH4, and then I have 2 moles of oxygen, 2 moles of O2, so moles of methane cancel out, and so now I can calculate the exact amount of moles of the oxygen I need to react completely with my 5 moles of methane. And when I calculate that out, it says I need 10 moles of oxygen. So this tells me that in order for me to completely react with my 5 moles of methane, I need at least 10 moles of oxygen. Do I have 10 moles of oxygen? If I have 10 moles of oxygen, then I have enough oxygen to completely react with the methane. If I don't, then I'm going to run out of oxygen first before I react with all my methane. So how many do I have? I have 8 moles of the oxygen. That's less than what I need. So I'm going to run out of oxygen before I am done reacting with all of my methane. So the reactant that I run out first is going to be the limiting reactant. So in this case, again, we identify oxygen as the limiting reagent because I don't have enough oxygen. I have less than the 10 that I need, so I'm going to run out of oxygen first. Oxygen is the limiting reagent. And then once I figure out which one is the limiting reagent, I can use that one and then, convert it to the amount of product I would get, because the limiting reagent is what's going to determine the amount of product possible. And that's going to give you the theoretical yield. Again, the theoretical yield is going to be based upon what the limiting reagent can give you. I hope that this is helpful. So those are 2 methods. The method I like the best, I think, in most problems is this one here, because most of the problems that they're giving you in the limiting reagent problem is going to ask you, please calculate the theoretical yield of some product. So because you're going to have to calculate the product anyway, you might as well just do it in the beginning, right? So in this case, if they're asking for a certain number of grams of product and you need to figure out what the limiting reagent is, well, just start with your reactants, the amount of reactants, and convert that to amount of the product that you're interested in, right? So here we were interested in carbon dioxide, so I would convert both reactants to the amount of carbon dioxide first, and then the lesser amount is going to determine my limiting reagent, which is oxygen. And then now that I have the product, I can then determine that as the theoretical yield. So here would be moles. I would just convert moles to grams, and grams would be my theoretical yield, or whatever unit they're asking for. If they want moles, then you're done. If they want grams, then you just convert using molar mass. So I prefer this method because it's already getting you to the answer that the problem is asking for, or most problems are asking for anyway. But either method is fine for determining what your limiting reagent is. I hope this is helpful. I hope you enjoyed it, and if you like the video, like it, share the video with your friends, subscribe to the channel, make a comment in the comment section. Tell me what you liked, tell me what questions you have, and make sure you hit the notification bell and so that way you get notified by any new videos that I put out. Thanks for joining me, and I'll see you next time.